Power on.
It says circle O at right is a unit circle. So the fact that it's a unit circle, excuse me, so tells us that the hypotenuse is 1. As theta becomes smaller and smaller, getting closer and closer to 0, what happens to sine of theta, what happens to cosine, and what happens to tangent? So we'll just start with one of those at a time. So sine of theta we know is opposite over hypotenuse, or would just be y in this case if this is y, because the hypotenuse is 1. So as theta gets smaller, so we'd have this triangle, this would be y, we have this triangle, and now this is y. It's getting kind of messy writing all those y's, but we're looking at the height. So we'd have this triangle, then this triangle, then this triangle, then this triangle. And it's kind of messy, but you can see that the height is getting smaller and smaller, and eventually when theta gets to 0, our height is also 0. So sine of theta is getting closer to 0. It's decreasing. Does that make sense? Hopefully. So cosine of theta, we know is adjacent over hypotenuse, or just x, because again, the hypotenuse is 1, and the hypotenuse stays 1 everywhere on this triangle. Or on this circle. So every triangle has a hypotenuse of 1. So if I do look at this triangle, I'm looking at this adjacent side. Toby! 1 second. Okay, sorry. So here we had, this was the base, then this is the base, and so the base you can see is getting bigger and bigger, because eventually when you get to 0, this is the base right here, which once we get to 0, it ends up being 1. So cosine of theta is getting closer and closer to 1. It's increasing from whatever it was to 1. And then tangent of theta is opposite over adjacent, or y over x. So remember, y is our height, x is our base. So here for this triangle, y is greater than x, because we can tell it's taller, and so it's more than 1. Then when we get our 45, 45, 90 triangle, we know it would be 1. Then when we get down here to like this triangle, I'll just draw it off to the side, where this is y and this is x, we can see that y is much smaller than x. And eventually, when we get down to this flat line, our y value is 0 and our x value is 1. So this would be 0 over 1, which means it's getting closer. So that's what it's approaching, which is equal to 0. Because tangent is getting smaller and smaller, because it's, remember, tangent is the same as rise over run or slope. Our slope is getting smaller and smaller and closer to 0 as we approach x here. So hopefully those triangles kind of help that make sense. If you have other questions on that one, let me know. Otherwise, that was kind of it for that one for now. Let's see. Yes, I'm going to go over number 4. I'm going to send a message to all of the groups letting them know. Okay, so number 4, it says a portion of a roller coaster track is to be built in the shape of a cosine curve. You have been hired to calculate the lengths of the vertical timber supports to be used. So the high and low points on the track are separated by 50 meters horizontally and 30 meters vertically. So it shows you that this is 50 meters. And then it shows us that it's 30 meters tall. The low point is 3 meters below the ground. So this down here is at -3 for that lowest point. Let y be the number of meters the track is above the ground and x be the meters horizontally from the high point. Write an equation to be the number of meters horizontally from the high point in terms for y in terms of x. So we know cosine equation is y equals a times cosine of b times x minus h plus k. So we want to write our equation like this. We know that it's 30 meters from the lowest point to the highest point, and it tells us that the lowest point is -3. So this highest point then here is at 27. -3 plus 30 would give us 27. That's kind of our high point up there. Our low point is down there. We know if this is 30 meters from lowest to highest, that we would kind of in the middle would be 15 and 15. So that tells us our A value, our amplitude is 15. So then what that tells us, or what that helps us find, that's going to help us find K. So A, B, P, or period, H, and K. So K then is in the middle. So you want to find kind of in the middle of -3 and 27, or you know it's 15 away from 27 and 15 away from -3. So if we subtract 15 from 27, somewhere around there, that's going to put us at 12. 27 minus 15 is 12. 12 minus 15 is -3. So our K value then is 12. Questions on that part so far? Okay. So then, let's see. It tells us the low point and high points are separated by 50 meters. So from the high point to the low point is 50 meters. So that tells us that the whole thing, when it goes back up to the high point again, would be 100. So our period would be 100. 50 points from high to low, then it would keep going back to the high and would be another 50. So that tells us our period is 100. So we know that our period is 2 pi over b. So if I plug in 100 and solve for b, so 100 equals 2 pi over b. Multiply both sides by b, 100b equals 2 pi. B equals 2 pi over 100, which if we reduce it is pi over 50. So that's our b value. And then since our high point is just here at the top, we'll just say h is 0. We're not going to shift it left or right at all. So kind of going back, it told us this was 30. So if I cut 30 in half, it was 15 and 15, which gave us our A value. And then I went down 15 to get our K value. It told us it was 50 meters from the highest to lowest point, which means it's another 50 from low to high. So our period would be 100. And then I just plugged it in and solved there. So that will let you then write your equation. Y equals 15 cosine of pi over 50 times x. There's no h. And then plus 12 on the outside. And then we want to know how long the vertical timbers are. So those supports at x equals 4 and x equals 32. You just plug it in. So plug in 4 here. So y equals 15. Sorry, it's kind of crooked. Cosine of pi over 50 times 4 plus 12. And you'll see what you get. And then you do the same thing when you plug in 32. Oh, and then, I forgot this one. Sorry. This is for this part at x equals 4. How long are the vertical timbers at the high point? This high point is right here. That's just going to be 27 at the high point, because that's where it's starting at its highest point. So hopefully that helps for number 4. Yes, you still have to calculate this, and then you have to plug in 32 also. But that should be it on that one. All right, so you are free to, is there another one? Anyone? I did 3 and 4. If you need something else, let me know. Otherwise, you are free to go back to your breakout rooms and try to finish up.
Can I see number 3, please?
Yes. I can do 5 after, yes. So here for number 2, it tells you draw an angle theta in the third quadrant. So third quadrant looks like this, because we know that angle goes all the way around like that. Okay, so then, so we know sine is negative 12 over 13. Again, sine is opposite over hypotenuse. So this would be negative 12, and this would be 13. You can also do it in fractions, where your hypotenuse is 1, but I think that way is a little bit harder. Maybe Miss I did it that way. I'm not sure. Maybe she showed you both ways. I usually show both ways, but I don't want to make it more confusing at this point. So sine is opposite over hypotenuse. So the opposite side, because this is our angle here that we're using, is negative 12, and the hypotenuse is 13. If we call this side x and do the Pythagorean theorem, so we get x squared plus 144 equals 169. We get x squared equals 25. So x is equal to plus or minus 5 when we take the square root. And in this case, because we went to the left, we know that x would be negative 5 for this triangle. So then cosine, we know, is adjacent over hypotenuse, negative 5 over 13. And tangent, we know, is opposite over adjacent. So negative 12 over negative 5, which ends up being just 12 over 5. Your negatives will cancel out. Does that make sense on number 2? Okay, so divide the following polynomials. So we're dividing by a quadratic, which means our box has to be 3 tall. I don't know how wide it needs to be. Well, So we know this is x squared 4x and negative 6. My box is very crooked, but that's okay. So same idea. So whatever we're dividing by goes over on the left. And this first term is 2x cubed. So we have to figure out what would be on top. And the same thing, these diagonals are going to be our like terms here. So x squared times 2x is how we're going to get 2x cubed. Well, then that gives us 8x squared. And below that gives us negative 12x. So again, these are going to be like terms. So we want 11x squared and we have 8x squared. That makes this 3x squared because we need 11. Well, x squared times 3 is how we get 3x squared. So this gives us 12x. And then 3 times negative 6 is negative 18. So right here, negative 12x and 12x, we have 0 x's left, which is what we want. Notice in this original, we didn't have any x's, but we wanted negative 21, and we have negative 18. So we don't need any more x's, but we need a negative 3 here to make this negative 21. So this is equal to 2x plus 3 minus 3 over x squared plus 4x minus 6.